My dear student, I am A.K. HAZRA from Salt Lake City, Kolkata. I wholeheartedly welcome you to School of Fundamental Sciences for our confidence building program. This intensive program will help you a lot to understand the fundamental concepts of physics, chemistry, mathematics steadily. I earnestly request you to study the content of our videos very carefully. I will be happy if you understand and enjoy the useful concepts. My heartfelt wishes for your bright future. Thank you. My dear student, now let us start balancing by ion electron method. It is almost similar to oxidation number method, but difference is what here. The oxidation half reaction will be completely balanced and the reduction half reaction will be completely balanced, and then we have to add them by balancing electrons. So let us see. There are several steps. Already I have explained very clearly in the sample example 18. I am explaining again. Now we have to balance the reaction by ion electron method in the basic medium. Now oxidation half reaction, ASO3 3 minus to ASO4 3 minus, plus 3 to plus 5. So 2 units of oxidation releasing 2 electrons. Now next, write the reaction without writing oxidation number, because the job of oxidation number already completed. 2 electrons we have written from the change in oxidation number. So ASO3 3 minus, ASO4 3 minus. Now applying charge balance concept, you see here left side 3 minus, right side 5 minus. Basic medium, so we must add 2 OH minus, so 5 minus 5 minus. So and then we have to adjust hydrogen. Left side 2 hydrogen, right side, so we must write water. So 2 hydrogen adjusted, and oxygen already adjusted, you see. So it is a balanced equation, oxidation half reaction. Equation number 1. Next, reduction half reaction. MnO4 minus to MnO2 plus 7 to plus 4. So 3 units of reduction. So 3 minus. Then again writing the reaction without writing oxygen number. Total charge 3 minus 1 minus 4 minus 0. So basic medium, we must add 4 OH minus here. Total hydrogen on the right side 4 hydrogen. So we must add 2 H2 here. So hydrogen already balanced. And then oxygen bound to be balanced. A balanced reaction. Now we have to find the what? Finally we have to find the balanced equation. Now in the reaction number 1, you see there are 2 electrons, and the reaction number 2 there is 3 electrons. So LCM is 6. So we have to make 6 electrons. So first equation is multiplied by 3, and the second equation is multiplied by 2. So we will have, when the first equation is multiplied by 3, we will have what? 3 ASO3 minus this one, and the second equation number 2 is multiplied by 2, so we will have this one. And then if we add the 2 reaction, electrons will be cancelled out, so we will have this one. It is a balanced reaction in the ionic form. Now AC19. It is an example of disproportionation reaction where the manganate disproportionates to permanganate and manganese dioxide. Disproportionation means the single radical, single ion or single compound will undergo both oxidation as well as reduction. It undergoes oxidation as well as reduction. So first you see oxidation half reaction, MnO4 2 minus manganate to permanganate MnO4 minus. So oxidation number plus 6 to plus 7. So 1 unit of oxidation, so releasing 1 electron, and already it is balanced. Total charge you see again MnO4 2 minus, MnO4 minus, E minus. Total charge 2 minus, here total charge 2 minus. 2 is multiplied by balancing the electron for reduction half reaction as well as oxidation half reaction. So later on you see why 2 is multiplied. Wait. Equation number 1. Now second again MnO4 2 minus undergoes reduction to MnO2 plus 6 to plus 4. 2 units of reduction. 4 minus 6 means minus 2. So 2 units of reduction. So 2 electrons are added here. So we will have MnO4 minus 2 minus MnO4 2 minus 2E minus MnO2. It is unbalanced one because total charge is 4 minus here. Here total charge is 0. But reaction is happening in acidic medium. So what will happen? It is a 4 minus, so we must add 4. Acidic medium means we must add H plus and water. So right side charge 0 and we have to add H plus, so we must add 4H plus in the right side. So 2 minus 4 minus and 4H plus, so total charge is 0. So charge is already balanced. Balanced hydrogen, here 4H plus, so we must write 2H2O here. So hydrogen is balanced. Oxygen bound to be balanced. Equation number 2. And if we add equation number 1 and 2, electrons are already balanced. So we will have this. This is a balanced equation. Now, sample example number 20. We have to balance the reaction by ion electron method. Here you see arsenic and sulfur both undergoes oxidation. Yes, you see arsenic and arsenic ASO4 3 minus. Arsenic has oxygen number 2 oxygen number plus 5 and plus 3. So here it is, you see plus 5 because oxygen is minus 2. So 4 oxygen minus 8. So arsenic plus 5. So we have 3 minus. Now first you see AS2S3. So 1 mole contains 2 atoms of arsenic. So it should be balanced. Key atoms first be balanced first. So arsenic key atoms, also sulfur key atoms. 1 mole contain 2 arsenic. So here also 2 is multiplied. So 2 arsenic adjusted. Sulfur 3. So 3 is multiplied here. Now arsenic oxygen number plus 3. For 2 is multiplied. It is a sulfide. So minus 2. 3 is multiplied here. Now here you see oxygen plus 5. 2. So 2 is multiplied here. Here sulfur atom, it is 0, 3 is multiplied here. So here you see what is the change. For arsenic plus 10 from plus 6, so plus 6 to plus 10. So 4 units of oxidation, so minus 4E. Sulfite minus 6 to 0. So 6 units of oxidation. So minus, because 0 minus of minus 6, so plus 6. So plus means increase, or increase in oxygen number means oxidation. So 6 units of oxidation, so minus 6E. Total minus 10E. Minus 10E means it will appear here as plus 10E. So ultimately we will have AS2S3 to 2SO4 3 minus 3S plus 10E, avoiding oxidation numbers because already its job already done. 10 electron already have obtained, but you see charge is not balanced. Total charge is here 16 minus because 6 minus and 10 minus 16 minus. It is happening in the acidic medium, you see. H plus means acidic medium. So here total charge is 16 minus, so we must add 16 H plus. So total it will be 0. 16 minus acidic medium, so we must add H plus and water. So first balance the charge in the right side. Left side 0, right side 16 minus. 6 minus 10 minus 16 minus and 16 H plus, so 0. Now balance hydrogen. Hydrogen 16 here, so 8 water, 8 H2O. So 16 hydrogen already balanced, oxygen bound to be balanced. So balance equation number 1. Now reduction have reaction. NO3 minus to NO2. NO3 minus to NO2. So plus 5 to plus 4. 1 units of reduction, so E minus. Then write normally without writing oxygen number. NO3 minus plus E. NO2 unbalanced, total charge minus 2 minus, total charge 0. Acidic medium, so we must add 2 H plus and the right side H2O because to balance water, hydrogen, 2 hydrogen here, so H2O. Oxygen bound to be balanced. Here 10 electron, here 1 electron, LCM 10, so 10 is multiplied here. So that it will be, it is balanced, already balanced. 10 is multiplied here, that's why electrons are balanced. Now add 1 and 2, we have this reaction. Accordingly, you see sample example number 21. And 21. It is a actually balancing of a organic reaction. organic reaction. Similarly, we have balanced the reaction same as before, but obviously to compute the oxidation number of carbon, you must take the average oxidation number. That is, you write the molecular form C4H. To balance the organic reactions, you take the oxidation number of each element, obviously carbon and others, average oxidation number. So that is written in the molecular form, and accordingly the oxidation number of carbon is obtained. For these one reactant products, the oxidation number of carbons are obtained, and then oxidation number you see for this carbon -6/4. So for 4 carbon 4 is multiplied. For this carbon already calculated, you see -2/3. For 3 carbon 3 is multiplied, and for this carbon already calculated here, you see it is a +2. So what is total change in oxidation number? Here you see it is a -2 and +2, 0. 3 multiplied is -2 +2. So right side oxidation number 0 and left side -6. For a change in oxidation number, 6 minus of -6. So 6 units of oxidation. That's why +6E minus is written. Now apply charge balance concept. C4H8, don't write oxidation number, already done. C4H8 giving C3H5O2 minus, CHI3 6 minus, total charge 0 here, and here 7 minus, unbalanced. The reaction is happening in basic medium. So we must add, yes, because of I3 we must add 3 minus, 3I minus and 4 OH minus. Total left side total charge 0, right side 7 minus. And there you see, remember that I3, 3I minus. So we need 7 minus in the left side. So how? 3I minus and then 4 OH minus. So total 7 minus adjusted. So balance hydrogen, 4 hydrogen. So 4 hydrogen, no not 4, 4 hydrogen plus 8, 12 hydrogen. So you see 3H2O, because 5 hydrogen here, 1 hydrogen here, 6 hydrogen plus 6 hydrogen, 12 hydrogen. 12 hydrogen balance, oxygen bound to be balanced. Similarly, reaction I2 to 2I minus accordingly we have met. And to find the balance equation, we must balance the electrons and then add them to get the balance equation. And in the molecular form also we can write 4 OH minus, we can write 4K OH, but 4K plus is added here. So 4K plus is 3K plus is added here, 1K plus is added here. So we can have 4K plus here, 3K plus and 1K plus 4K plus. We have the molecular form also.